the B families, there are two groups of these B families: the early transition elements and the late transition elements. These elements are located between the 2A family and the 3A family in the periodic table. Those are the families of the elements in the periodic table. So let's go now to the periodic variation of the elements in the periodic table. By periodic variation, it means the trend and how they are being arranged in the periodic table. These are the periodic variations of the elements as arranged in the periodic table. 1, we have the atomic size. 2, we have the metallic property. 3 is the ionization energy. 4th is the electron affinity. And 5th is the electronegativity. When we say the atomic size, this refers to the number of energy levels which the electrons occupies. So if there is only one electron of the atom, it only occupies the first energy level. However, in the example like sodium atom, since there are 11 electrons in the sodium atom, so the farthest electron will occupy up to the third energy level. If you have the sodium atom, there are 11 electrons. And if you're going to make the electronic configuration of this sodium atom, the last electron is found at the 3s orbital. So that means the electrons are distributed up to the third energy level. So the size of the atomic atom can be said that there are 3 energy levels. If you're going to look at the next element going down the periodic table, it is potassium. And potassium has 19 electrons. And if you get the electronic configuration of the element potassium, the last electron is found in the 4th energy level. So we can say that the atomic size of this element, potassium, reaches up to the 4th energy level. So if you're going to look at the atomic size of the elements as arranged in the periodic table, as you go down the periodic table, the atomic size increases. But as you go across the periodic table, the number of electrons in the atom chlorine, which lies on the same period that of sodium, the last electron or the valence electrons of chlorine will only occupy the third energy level. So if you go across the periodic table, there seems to be no change in the number of the energy level. Likewise, if you go farther right of the periodic table, potassium to bromine, bromine has 7 electrons occupying the 4th energy level. So there seems to have no change in the number of energy level. So as you go across the periodic table, it can be concluded that there is no change in the atomic size. And it is said that there is a decrease in atomic size. Why? Because there is the tendency of these electrons to be compacted towards the nucleus, which is positively charged. There is a strong attraction between the protons in the nucleus and the electrons in the energy levels. The second periodic variation is the metallic property. If you're going to look at the periodic table, on 1A family, the topmost element there is a hydrogen. So as you go down the periodic table, the metallic property increases. But as you go across the periodic table from left to right, take note, you start in the second period like lithium. If you go farther right, you can find the gas neon. So the metallic property is decreasing from a metal going to being a nonmetal. Likewise, in the fourth period where potassium is found, it starts with potassium, which is metallic, and you go across the periodic table. At the end, there is krypton, which is a gas. So you can say that as you go across the periodic table, the metallic property decreases. Another periodic variation is the ionization energy. Ionization energy is energy required to remove an electron from the atom in order to form a cation or a positive ion. Now, if you take note that as you go down the periodic table, the ionization energy decreases, while as you go across the periodic table, the ionization energy increases. Another periodic variation is the electron affinity. By electron affinity, this is the energy released by an atom in order to gain an electron. So, gaining an electron will form a negative ion. As you go down the periodic table, the electron affinity decreases, while as you go across the periodic table, the electron affinity increases. Another periodic variation is the electronegativity. By electronegativity, it means the ability of the atom to attract electrons toward itself in a compound formation. As you go down the periodic table, electronegativity decreases, while as you go across the periodic table, the electronegativity increases. So those are the periodic variations of the elements as arranged in the periodic table. Then let's go to the different groups of elements in the periodic table. The first group of the elements in the periodic table is the representative elements. Now, these representative elements includes the 1A, the 2A, the 3A, 4A, 5A, 6A, and 7A elements. These elements will fill up the s and the p orbitals. And there is one energy level which is incompletely filled up with electrons. For example, the element magnesium. There are 12 electrons, and when you're going to write the electronic configuration for the element magnesium, you will have 1s2, 2s2, 2p6, 3s2. So it fills up the s orbital. And there is one energy level which is incompletely filled up with electrons. So what must be this energy level? It is the third energy level, because there is only the s orbital which is being filled up. Supposedly, in the third energy level, there should be 18 electrons. However, in magnesium, there are only 2 electrons filling up the third energy level. Then there is the what we call noble gases. In the noble gas, these are the 8A elements, and they fill up the p orbital completely. For example, neon. Neon has 10 electrons. So if you're going to get the electronic configuration for neon, that is 1s2, 2s2, 2p6. So the p orbital is completely filled up. The third group of elements in the periodic table is the transition elements. These transition elements fills up the d orbitals, and there are 2 energy levels which are incompletely filled up with the electrons. For example, scandium. where it has 21 electrons. If you're going to distribute these electrons using the electronic configuration, then you have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. So it fills up to the d orbital. And what are the two energy levels which are incompletely filled up with electrons? Usually, the last two energy levels are incompletely filled up with the electrons. Let us try to check. In the fourth energy level, there should be 32 electrons in order to be completely filled up. However, for scandium, it has only 2 electrons filling up the fourth energy level. And going backwards, you have in the third energy level, there must be 18 electrons to fill up completely the third energy level. However, there are only 9 electrons filling up the third energy level. So the two energy levels which are incompletely filled up with electrons are the third energy level and the fourth energy level. Then the fourth group of the elements in the periodic table is the inner transition elements. If you're going to look at the periodic table, you can see at the last two periods, there is an arrow joining the lanthanum and the actinium. So this group, starting with lanthanum and the actinium, are called the inner transition elements. In the inner transition elements, they fill up the f orbital. And there are 3 energy levels which are incompletely filled up with electrons. For example, the lanthanum. Lanthanum has 57 electrons. So if you're going to make an electronic configuration of this lanthanum, you can find that the last electron, we call it the differentiating electron, is distributed to the f orbital of the fourth energy level. So what must be the 3 energy levels which are incompletely filled up with electrons for this element lanthanum? These are the 6th energy level, the 5th energy level, and the 4th energy level. You try to see if you're going to make the electronic configuration, and you can check that in the 4th energy level, it should have 32 electrons to complete the energy level with electrons. In the 5th energy level, there are only 8 electrons of lanthanum occupying the energy level. But supposedly, there should be 50 electrons occupying the 5th energy level. In the 6th energy level, there are only 2 electrons of lanthanum occupying this energy level, which is supposedly that in the 6th energy level, there must be 72 electrons. So those are the 4 groups of elements found in the periodic table. Again, they are the representative element, the transition element, the noble gases, and the inner transition elements. So I have completely discussed the whole chapter on the atomic structure up to the periodic table. So next meeting, I would like to give you a quiz. That would be all for today. This is your teacher, Professor Nisitas Ruiz of Holy Name University.